Now that we know what rational functions are, a lot of the rest of chapter 12 is doing operations with fractions, but this time fractions that have x's in them. So to start, we need to make sure we just remember what to do with fractions. So first question is, can we reduce these fractions? Why or why not? So 4 over 8, does that fraction reduce? Yeah, and reducing means dividing the top and bottom. So we have to be able to divide the top and the bottom by the same number. And in this case, you could cut it in half, but if you see that 4 goes into both, you get to the reduced form even quicker, because 4 over 8 is just the same as 1/2. No problem. 10 over 11. Nothing divides 11 except 1 and 11, and those don't go into 10, so this cannot be reduced. Because reduced means you have to divide. Now, why this is important to realize is because once we have x's involved, what we might see is something like 9 plus 1 over 9 plus 2. This is still 10 over 11, right? 9 plus 1 is 10. 9 plus 2 is 11. So this is 10 over 11. Some people tend to want to cancel a fraction when there's addition or subtraction in there, and that never works. So do not do that, right? This is not the same as 1/2. 10 over 11 is nowhere near 1/2. But if we think we can cancel when we have additions, we start doing things like this. So do not cancel a fraction if there's addition subtraction. It has to be factored. So that's another use for factoring. Factoring enables us to simplify fractions. So another way to look at this first one, instead of doing it like I did, we could start over and do 4 times 1 over 4 times 2. That is still 4 over 8. When there's multiplication, that's exactly when it works to just cross out these 4's. So as soon as we have it in factored form with multiplication, then you can cancel, but you cannot cancel with addition subtraction. So hopefully that, that's a good example to sort of lean on them to remind yourselves. All right, so when we multiply and divide rational functions, we're going to start with multiply and then do divide. This is the same as multiplying or dividing fractions. It's the same rules apply. So we want to, make sure we review how to multiply fractions. So one thing you want to do is reduce common factors before you multiply. So look for, again, factors, right? We have to factor everything, but look for common factors before you multiply. Makes it a lot easier. So here's an example of just how to multiply fractions. 2/3 times 5/7. We multiply the top numbers, we multiply the bottom numbers, we get 10 over 21. Pretty easy. Actually, I hope a lot easy. But, and at the end, we can't reduce that fraction. And that's because in the first step, 2 and 7 don't have any common factors. 3 and 5 don't have any common factors. So we're going to try to look for common factors before doing this multiplication. But at the end, the multiplying is just across the top, across the bottom. All right, so let's do some where there are common factors. So we want to look along the diagonals especially to see if there's something we can divide both the top and the bottom by. And 7 goes into 14. So I can divide by 7, divide by 7. So all I did here in this diagonal is divide by 7 to reduce. Let's do the same on the other diagonal. And I'm not worried about that negative. We'll deal with that at the end. But 15 and 30, what can we divide? Oh, 15 goes into 30. So we can divide by 15. Divide by 15, divide by 15. So in that diagonal, we divide by 15 to reduce. So we're trying to divide the top and bottom by the same value. Now we do need to make sure we don't neglect this negative sign, but now what we've reduced it down to is negative 1/2 times positive 1/2. Right, because 15 over 30 was a half, 7 over 14 was a half, and that negative's hanging out. So in that case, now we just multiply the tops and the bottoms and we get negative 1/4. Typically with fractions, you want to put the negative with the top number. So when it's sitting out in front like that, I usually just move it to the top number. That helps me at least. All right, so if you've, if you've always waited till the end to reduce, this might be somewhat new. This is a lot easier than multiplying first. You would need a calculator to do 14 times 30 and then trying to figure out what divides these big numbers. It's a lot easier to see that 7 and 14 have 7 in common and 15 and 30 had 15 in common. All right. Oh, I said we we're going to wait to do divide, but here's some dividing. This is still reviewing old stuff, I guess. So to divide a fraction, divide fractions. One sort of trick that you may have heard is keep, change, flip. A student taught me that a few years back. If you've never heard of that, you don't have to use it. But the idea is that you keep the first fraction, change to multiply, and then flip the second fraction. And we got to do that before we start canceling. So we're going to keep the first fraction, 5/7, change the divide to multiply, and then flip the second fraction. And just like I said before, I'm going to move that negative to the top number. We don't, we put parentheses here because otherwise it would look like a subtraction. And that's another thing that moving it to the top number does, is it makes it look not like a subtraction then. All right, now we're going to cross cancel. 5 goes into 20. So I'm going to divide by 5, divide by 5. On that diagonal. And then on this other diagonal, 7 goes into 21. So I'm going to divide by 7. 7 divided by 7 is 1. Divide by 7, that'd be -3. So those are both divide by 7. And then we're just going to multiply the tops and the bottom. 1 times -3 is -3. 1 times 4 makes 4. So this ends up being -3/4. Let's try another one because, dividing has that extra step of keep, change, flip. So first step, keep the first fraction, 5/12. Change to multiplication, flip the second fraction, 6/25. And now cross canceling. 6 and 12, we can divide by 6 along that diagonal. Along the other diagonal, I can divide by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So if it helps you, I'm writing these out just in case that helps you notice. Because especially, when students learn this in ALEKS, they just see numbers crossed out and other numbers written on top. So hopefully that helps sort of trace where these numbers came from. If it helps you, you can rewrite the numbers now. So instead of 5, we have a 1. Instead of 12, I have a 2. Instead of 6, I have a 1. Instead of 25 is a 5. So now to multiply the tops, multiply the bottoms, we get 1/10. So that's the same as 5/12 divided by 25/6. It's 1/10. All right, let's box these in, make sure we can see the answers. There's a lot going on in these problems. Okay. So the other thing, so that's just reviewing how to multiply and divide fractions. The other thing we need to remember is factoring. Hopefully by now we're factoring experts, but if not, let's do a quick review of some factoring rules. First, if there are two terms, that's probably difference of two squares. Remember, that's where it's something squared minus something else squared. So in this case, x squared is x squared, and 5 squared is 25. So then it's x minus 5 times x plus 5. So often when there's just two terms, we see that difference of two squares. But here's an exception. So 7 is not a perfect square. The exception to this is to always look for a GCF first. Look for a GCF first. If there's something in common, in this case there's an x in common, we need to deal with that first. So factoring out the common x is the same as dividing by x. X squared divided by x is x. 7x divided by x is 7. The minus stays put. You can always, verify through multiplying this out. Same with this. You can FOIL and check that these work, but that is fully factored now, right? So always look for a GCF first, but then if there's two terms, usually it's difference of two squares. Now, when there's three terms, we have to pay attention to whether there's an a or not. So if a equals 1, like this one, then we just find two numbers that multiply to the last number and add to the middle number. It's when there's a number other than 1 in front of the x squared that we have to use AC method. But this one, I don't have to use AC method. I just need to multiply to 16. So that's either 1 and 16, 2 and 8, or 4 and 4. Which one of these would add to negative 8? Oh, wait, we need to make these both negative. And then a negative 4 times a negative 4. Multiply to a positive 16, but add to a negative 8. So this would be x minus 4 times x minus 4. Or, the better way to write this, if you see it, is x minus 4 squared. So that's best way to write the factored form. All right, so hopefully that's a quick review of factoring. The AC method is more complicated, but we will need it sometimes. Just to sort of recap what we discussed at the beginning, because it's so important that you have to factor before you cancel a fraction. All right, so here are some incorrect examples. X plus 2 over x plus 7. You cannot cancel these x's when there's adding or subtracting happening. X squared minus 4 over 4. You cannot cancel those 4s. Right? Like none of these work. So let's look at what x squared minus 9 over x minus 3 should look like. What we should be doing is factoring first. So we factor the top, that's a difference of two squares, x minus 3, x plus 3. And then the x minus 3's can cancel because it's factored. So we have to factor before we cancel a fraction. Before reducing a fraction. Because reducing a fraction really means dividing the top and bottom by something, not subtracting the same thing or adding the same thing. That doesn't work.